All right. Thank you everyone for joining. If you are seeing and hearing this, it means that you're watching the live stream. So please ask any questions that you're going to have today in the chat as I go through our topic. I'm going to walk through some quick slides and then I'm going to show you all a demo. And at the end of the demo, I'm going to circle back to the chat and answer all of your questions. So I'm excited to have you all here and let's just jump into it. Hi, I'm Franz Perez, Cyber Skyline, and today we're going to be learning about decompiling Java classes. Let's first start with how compiling works. And most programming languages, they can be categorized as either compiled or interpreted languages. With compiled languages, the human readable source code needs to be converted, otherwise known as being compiled, into a machine readable code. And this is often referred to as the binary. The machine readable code is specific to each operating system. So if you write a C program and you want it to run on both Windows and Mac, you're going to have to create one, or you have to compile one version for Windows and another version for Mac. The Windows binary is only going to work on the Windows machines, and the Mac binary is only going to work on Mac machines. Now, with interpreted languages, the human readable source code is not run directly by the operating system. Instead, it's run by the interpreter, and the interpreter is able to run the human readable source code without any intermediary compilation step. So it actually does the conversion from the human readable format into the machine readable format on the fly, like as the program is running through the interpreter. So going back to Java, Java is considered both a compiled and an interpreted language. The Java source code, the human readable code, has to be compiled into bytecode. And this bytecode cannot be run directly by the operating system. It actually needs to be run by the Java virtual machine, or the JVM. And that acts very similarly to the interpreter. And there are different versions of the JVM for the different operating systems that it supports. And so the same exact bytecode, whether or not you're going to run it on a Windows machine or a Mac or a Linux machine, as long as they're all installed with the compatible JVM, the same bytecode should run the same way on all of those different versions. And in the images that I have here on the left one, the hello.java, you can see that is the human readable code. So you can see here public static void main, and then all this program is doing is just printing out the words hello world, and that's it. Now, to actually run this, we need to put it through the Java compiler. That's this arrow in the center. And then on the right side, directly above me here, we have hello.class. That's the machine readable format. And that's what happens when you try to print it out. It's just gibberish, right? The machines can understand it. It's not human readable. So when you reverse engineering, you'll often find it that it's helpful to be able to retrieve the human readable format, the source code, from the bytecode. You might have access to just the compiled version and you want to get back to the human readable version. And that's what you use decompiling for. And the idea behind decompiling is pretty straightforward. We just want to reverse the process of compiling. We're just going backwards, right? We want to turn the machine readable bytecode into human readable source code. So you can see here, I swapped the two sides. We have the machine readable version on the left and the human readable version on the right. And in order to go from one to the other, we need a decompiler to do this. What the decompiler will do, it's a program that will analyze the bytecode, and then it will attempt to reconstruct the source code by using some strategies and educated guesses as to what source code could have been there to compile into the bytecode that you provided. So the important thing to know here is that it's really kind of it's more or less an educated guess, because it's seeing the final version and it's guessing what input resulted in this final version. It doesn't have a direct one-to-one going backwards. And so different settings during the compilation process may affect how accurate this process can be. With Java, generally, it's pretty accurate for the most part to the original, with the kind of the big exception being variable names and some formatting. When you're looking at other compiled languages, there are like different settings within the compiler that will like add additional obfuscation. There's also some ability to kind of like remove the mapping table to make it even harder to get the original like variable names, for example. But the important thing to note is that if you're using a valid decompiler, a successful decompilation is always going to result in source code that is functionally identical to the original source code, meaning that it will, when you run it, it will work the exact same way. It might not look the same way as the original, but it will work the same way as the original. So in particular, I already called out the variable names is something that's super common that is lost. And you can actually see here, I have highlighted it right above me in the decompiled version, this param array of string. And that was not the original variable name here. So this is the decompiler creating a kind of a placeholder because it doesn't know the variable name. And so it's calling it param array of string so that you at least know that this is an array of strings. That's not the actual variable name. So that's something to keep in mind. Oftentimes after you do the decompilation, if you need to continue with reverse engineering, you might often need to kind of go through the code line by line and start renaming the variables so that they're more helpful to you so that you know what they actually mean. Because right now, this param array of string is not particularly helpful. And this is a relatively simple program, so you might not need to actually bother with renaming the variables. But when you're looking at a much longer program that you've decompiled, it may be very helpful, especially if you're having multiple different functions. Those function names can oftentimes not be carried over. And so you might want to like look at what the function is doing. And then based on your understanding of what it's doing, you might want to rename that function, because not so much with decompiling Java, but other languages, other binaries, I oftentimes will see function names which are just like A, B, C, D, E, and that's not helpful at all. Or they might be the name of the like the offset in memory for that function. All right. So before we move on to the demo with the decompilation, I want to go over a few useful commands, and all of these are assuming that you're running Kali Linux. So my head's a little bit in the way here. I'm gonna move myself out of the way. I tested this with Kali Linux. So if you want to try this yourself, you could probably use any apt-based system to do this, but I did this with Kali Linux. Three things here. Number one, you want to know how to run a program using Java. The Java program should be pre-installed on Kali, so you don't need to install it. And you just run a Java program by typing in Java, followed by the name of the file, the Java file that you want to run. The next command here is to install JDGUI. That is a Java decompiler with a graphical user interface, and that's what we are going to use. Now, once you have JDGUI installed, you will be able to decompile a Java class file by using the command jd-GUI, and then that's followed by the class file. So that works exactly the same way as just running it, but instead of using the Java program, we're going to use the jd-GUI program to do that. All right, so now we're ready to try this out, and let's take a look at our demo environment. Okay, so I'm here in my Kali Linux environment. And I'm taking a look at this challenge in our practice environment here. I've already downloaded this timebomb.class file. That is the file that we're going to be decompiling. And we have a couple questions here. And so let's go and try to answer them one at a time. So the first one is, what programming language is the program written in? Might be a little bit of a spoiler considering that you're watching this video, but this is a Java program. The way that you can find out this information is if you Google this .class file extension, you will get results that kind of indicate to you that .class is used for compiled Java bytecode. So that's how you would get this first question correct. The next question is asking, what exit code does the program exit with when it is not time? So this is going to actually require us to interact with the program itself. And so I've already downloaded it here, and I'm in my downloads folder. So what I'm going to do is I'm going to, assuming that I didn't really know that this was a compiled file, I would try to open it and read it. And you can see here that when I do that, it's not particularly helpful. It's a lot of gibberish. And I can also run a hex dump on the file. And you can see here that there are some human readable text in here. I can see here, there's this timebomb.java, and that's listed as the source file. So this must have been the name of the file before it was compiled into this .class file. I can see some references to some libraries. So there's this print stream library that's being used. And so I can also see this text here. It isn't time yet. So that's probably some text that is directly, it's a string that's directly within the program itself. But anyway, we can't really tell what it's doing from this view. So what we need to do is I'd first try to run it. So if I run Java on this time bomb program, I can see here it says boom. So I don't know what's going on, right? I just try to run it. It just says boom. If I just type in random values, it's just boom. Okay. So we actually need to decompile this because when we looked at the file, there was nothing useful there. We need to go and get some human readable source code. So I'm going to run this jd-GUI, and I'm going to specify the timebomb.class file. If I hit enter, this thing runs. Funnily enough, this JD, the Java decompiler, is itself a Java application, which I find pretty ironic. And you can see here, and I don't know if I can make this any larger. Let me see. Preferences. All right, let's just crank up the font size here. All right, perfect. So we can see here, this is the program. It's a pretty short program. And I can see it isn't time yet. There's also a boom in here. And these are strings. So those translated pretty well because those need to be kept intact for that text to be printed correctly. But variable names are not preserved. So I have this param array of string. That's what we saw in the slides earlier. And we also have this double D, system.current time in milliseconds, current time millis. And the variable is called D. I assume that it came up with the variable placeholder name D because it's a double. So I don't know from this decompilation what the name of this variable was originally. I just know it as this D. So we lost that information here. Okay, but we have successfully decompiled the program. So now we can take a look at the question, and it's asking what exit code does the program exit with when it is not time? So this should be pretty straightforward because there's only one condition in here. We have an if else, and if it isn't time yet, so the question is asking when it is not time. If it is not time yet, it exits with the status code 10. Another way that we could verify this is if I open another tab, I go into my downloads folder, and then if I run Java with the time bomb here, it prints out boom. So when I am able to successfully get past this if statement, I can print out the return value. Oops, that's not that's the return value. Okay. I can print out the return value and it will spit that out to me. So in this case, the return value is 0. And if I look at the code, I can see here that if it does do a boom, it's supposed to have a return value of 0. And if we wanted to see the return value of 10, it looks like what we would need to do is change our current system time to be less than this value. So that's what we would need to do. But back to the original question, what exit code? The exit code is 10. And now we're being asked in what time in UTC does the software go boom? So we need to do a conversion. We have this number. So if I take this number and I copy it somehow, it's going to be quite unfortunate if I don't have a good way to copy this. Copy. All right, perfect. All right. And if I just go into a, I don't have Node installed on here. Well, I am going to look for a terminal, command line terminal for a language where I can just see if I can get the value of this, number here. So if I copy and then paste, of course, the clipboard does not work. So what I'm going to do instead, I'm going to save this in my downloads folder. Actually, can I just copy? Can I paste this here? Perfect. Okay. So I'm going to save this as a file. And then I should probably name it something that would make more sense here. So I'm going to rename this from out to timebomb.java. And if I now open my timebomb.java file, I can see here that we have this this number that we need to calculate the value for. So let me come in here, copy, see if I can get the value of that. Man, it is not happy with my my clipboard. Okay. 658-06352E12D. All right, so we need to find a converter for ourselves. So Java number, or can I just like Google search this? Okay, that's not helpful. Well, what we have right now is actually an online Java compiler. So to simplify this process, what we could do is just have this value for D, paste it in here, and then just print it out. Because I do not have the Java compiler installed on this machine. So I'm going to see if I can use this online program to print it out. Cool. That is, oh, okay, the D stood for a double. So this should be in scientific format notation. If I go to like Wolfram Alpha, I can come in here. Hopefully I can paste that value. All right, and it gives me an actual number. And what if I then go and do Unix millisecond timestamp converter? Okay, so I'm going to take this value, paste it in here, and we can see here that we've got what appears to be Sunday, July 17th, 2022. Okay. So let's see if that works. Hopefully we got this right. Looking at July 17th. And then the time is 1 p.m., 1:12 p.m. Okay, so we're looking at 1:12 p.m. All right. Fingers crossed we got this right. Hey, there we go. So we were able to successfully complete this this challenge here. Now, I ended up having to use this online Java compiler to be able to kind of like convert this number into like the human, human readable version. I think what I learned is that this uppercase D at the end in Java indicates that this is a double, if I had to guess. And the rest of it before that, that's just in scientific notation. So when I just put that into Wolfram Alpha, it kind of like expanded it for me. And then from there, I copied and pasted this into a milliseconds to UTC date converter. And the reason why I know that this is using milliseconds is because right here, it's calculating system.current time in milliseconds. So a little challenge for you all, if you got to this part of the video, try to change your system time and see if you set your system time to be before this date, this July 30th, or sorry, July 17th, 2022 at 1:12 p.m. If you try to set your date to just say like July 16th or July 15th, if you want to be very safe with the time zones, see if you can get the program to print out boom and, see if you can get it to print out it isn't time yet, and check to see if the status code that gets returned is 10. Because if you run the program and it goes boom, then your status code is going to be 0. But if it does not go boom, your status code should be 10. So hopefully you all found that helpful. And I'm gonna take a look at the chat and see what questions you all have right here in the chat. Okay, Kyle's asking, now that Oracle owns the Java runtime environment and has made changes to how they license the software, how does that affect the use of its platform for these purposes? I have not looked at specifically the Java licensing when it comes to like decompiling and like other reverse engineering. So I can't give you an answer directly to that, but I do know that Oracle has owned the Java runtime environment for quite some time now. So unless something has changed, I'm not, I don't think it's fully, I'm not fully aware of the implications there. Yeah, something to look into. I would hope that they don't do something unreasonable, like make it against their terms of use. But keep in mind that even if it's against their terms of use, it's code that's running on your program in your environment. They don't really have, unless you're paying money for some sort of license, what can they do to you specifically? They can't really fine you. Okay. A question about, do you recommend Visual Studio Code? That's personal preference. I personally use Vim. That's kind of what I've been using for a long time now. But I know a lot of people who use Visual Studio Code. If you like using a graphical editor, that's a very common one that a lot of people use. Patrick is asking, where can we download the demo code? Can someone post a link? So if you have access to the NCL gym, you will, if you go to the gym, this challenge is under enumeration exploitation, and I believe it's called Time Bomb. Okay, what else we have here? In terms of coding languages, what languages would you say the most common when it comes to having to do things like this challenge? So there isn't necessarily a common language. If you overall, if you're looking at like easy versus medium versus hard level reverse engineering challenges, the easier ones are going to be the ones that are the interpreted languages rather than the compiled languages. So like if you look at Python, well, actually, bad example because Python has PYC files, which are like compiled versions. JavaScript, for example, JavaScript is an interpreted language. And so that's more of a easy level reverse engineering challenge because you have the source code, there is no compiled version. And then the next one up would be those hybrids. So like a Python PYC file or a java.class file. And then the harder ones would be the fully compiled languages like a C or a Rust, Go. Those are going to be some of the harder reverse engineering challenges. And but I wouldn't say that there is necessarily like a particular common language more than whatever is common for programmers to use. All right. And then another question in here. What languages would you recommend to learn? Python, C#, SQL, etc. So it depends on what you are looking to do. If I'm speaking kind of in general for people who are trying to get into cybersecurity, I would highly recommend learning the Linux command line in Bash. So running Bash scripts is going to be very helpful, very useful thing to do in terms of automating some tasks. And to extend that further, I would recommend learning Python. That seems to be a pretty common language that gets used for kind of like sysadmin tasks or other IT and cyber tasks. So those are pretty common. And then the other languages beyond that would be kind of more to do with specialization. So you mentioned in there like C#. That's typically going to be more useful if you are going to be like writing applications. So if you're going to get a job where you're being a cybersecurity analyst, you're not writing programs, then you don't necessarily need to know C#. Maybe if you're reverse engineering programs, learning C# might be helpful specifically for reverse engineering C# programs. So that's going to depend. And for SQL, that's going to be for databases. And so if you're going to be working with databases, if you're going to be like a database admin, maybe you're programming and having to interface with a database, then that might be more helpful. I think having some general knowledge of SQL is generally useful because databases will regularly come up within cybersecurity. You just might not need to be super well versed in like having to write complicated queries with like joins and unions and all those things, but generally like understanding how to do a selection from a SQL database might be helpful. But it is going to be very, very specific to the role that you want and your career. But my top two recommendations: learn how to use Bash. I hesitate to call Bash a language, but being able to write Bash scripts is very helpful. And then Python is a pretty generally applicable and helpful language to learn. All right. Any other questions from the chat before we wrap it up for today? More of a comment here, but I saw someone in the chat mention that you can install Vim on VS Code. Yeah. There's also a bunch of other plugins for VS Code as well that you might find helpful. Something that I have been wanting to take a look into is that there are plugins for like the Microsoft Copilot AI. And so I'm trying to figure out ways to like kind of automate some tedious tasks. So if I have to go and do a refactor of some code and like it's the same, maybe I'm changing the name of a function and all the code that calls that function has to be renamed to match the new name, right? There might be some plugins directly within VS Code that can help you do that, or you might be able to ask the Copilot to like do all of the changes for you, have the AI go and do the renames for you. So VS Code is something that I kind of wanted to take a little bit more of a look into because some of those plugins can be pretty helpful. All right. Well, that looks like all of the questions in the chat. Want to thank you all again for joining. Hopefully you all are, most of you are here preparing for the NCL season. And if you are not yet signed up, make sure you go and sign up for the NCL season. I believe registration closes in about like 2 weeks or so. And once you register, you can get access to the gym immediately, and you can actually run through this exact challenge that I ran through today. And also, if you haven't, we do have a Discord channel. I'm going to put the banner up for that. But you can check out our Discord server, and you can find other NCL players there and get advice, ask each other questions. It's a great way to kind of get help and practice. And also, after each game, we do a debrief where we will cover how to solve the different challenges. So hopefully we get to see you all over there. So with that, I'm going to wrap up today. Hope you enjoy the rest of your evening, and take care.